right? Minus capital expenditures in 2012. Minus dividends in 2012. Minus change in net working capital in 2012. Okay?
You move it up.
Yeah, there you go. So the net income we get from the income statement, it's 4440. The depreciation is also from the income statement, and that's 2300. The capex we calculated in Part B, that's 11300. The dividend we calculated in Part C, that's 3140. And the change in net working capital we calculated in Part D, that's 700. So, when we add all these things together, we get negative 8400K. Or negative 8400, okay? So, conclude that the manager plans to issue $8,400K, 8.4 million, in long-term debt. We'll assume that that's how the manager makes up the difference. He issues long-term debt. All right, so any questions about this one? Is it clear? Basically, the question is asked to go and look at your equations and you find the equation that seems to apply. And grab your numbers from the net income statement or the balance sheet. So that's part E. Part F, I asked what will be the change to the leverage ratio due to these decisions? Question's a little trickier, not that bad. Okay, so first of all, let's try to find out what the leverage ratio is in 2011, as in the percentage of debt to total assets. Okay, so the long-term debt in 2011, well, we know that the long-term debt in 2012 is 12,400, and we know that the manager is going to issue 8,400 long-term debt this year. So we know that that difference is the long-term debt in 2011. Okay, so that's 12,400 minus 8,400 equals 4,000. Does everybody see that? If you had 4,000 in long-term debt this year, and the manager issued another 8,400 worth, then you get 12,400, which is exactly the number on the balance sheet, the pro forma balance sheet. Okay? The value of the assets in 2011, which we don't know, but we can calculate, is equal to, well, it's equal to the liabilities in 2011 plus the equity in 2011. The liabilities, there's 2,000 in current liabilities, don't forget those, plus the 4,000 in long-term debt, and the equity is 21,000. That was given in an earlier question. And that's equal to 27,000. Okay? So the leverage ratio in 2011 is equal to 4,000 in long-term debt, 2,000 in current liabilities, divided by 27,000 as the total value of the firm. That's equal to 22.2%. Okay? And the leverage ratio in 2012, well, we have that there's $15,000 worth of liabilities because there's 12,400 in long-term debt and 2,600 in current liabilities. Okay, so that's 15,000. So you can jot down some of the 15,000 is the 12,400 plus the 2,600. Okay, divided by 37,300, which is the total value, which we already have from the pro forma. It's the value of the firm. So leverage ratio in 2012 is 40.2%. So based on the manager's decisions, he's going to raise the leverage ratio from 22.2% to 40.2%. So the manager has big plans for the leverage of the firm. He has big plans for what to do with the cash this year. And so you as a CEO can infer that information, or if you knew the pro formas as an investor, you could could also look for that information, find out what the funds are. Alright, so that's all I have to say about pro formas. Any other questions, or any questions at all about pro formas or this question? So if we're good, then I'm going to move on to financial options, okay? So now we're on the Friday slides, okay? So, okay, financial options, a few concepts here. Make sure you know the payoffs. Yeah. And both are candidates, I would think. You know, it would be something that you could complete in a reasonable amount of time. You know, so if I did ask you to construct a pro forma balance sheet, it would probably have to be a short version of one, because that takes a bit of time to construct a pro forma balance sheet. Whereas this, you can do a little faster, if you know what you're doing. Okay? So, I'll get started on financial options here. So, remember that these are the payoffs of the four different types of option strategies, simple option strategies. For a long call, the payoff is the positive of max of ST minus K comma 0. Okay? Short call, there's a negative in front of that. If you're long a put, it's positive max of K minus ST comma 0. And if you're short a put, there's a negative in front of that. Okay? So if you were long a put and short a put, the payoff would be the addition of these two things. And maybe there are different strike prices or something. Okay? And then you could find the payoff function by looking at the payoff that you get for different ranges of strike prices. So, as a short example, suppose you were long a call with strike price $50 and short a put with strike price $40. Well, this is the payoff of a long call. And if you recall the payoff function, you make the table and you put the payoff in the top right of the table, and then you fill in the table according to the ranges of strike prices. So, max of ST minus 50 comma 0, and being short a put is minus the max of K minus ST comma 0. So you add those things together to get your payoff. Okay? So, this is the payoff function. Payoff function is right here. Okay? It looks like this. So, you have to consider different strike prices. Here, there are 2 strike prices, therefore you have to consider 3 ranges. When there are n strike prices, you have to consider n plus 1 ranges. Okay? So, when the stock price is less than 40, the call option is not in the money, right? Because if the stock price, for example, is $30, then the max of 30 minus 50 comma 0 would be 0. And then the put is in the money, unfortunate for us because we shorted the put, so we get minus 40 minus ST, where ST is just a general value for any ST less than 40. So, we get ST minus 40, that's the function for when the terminal stock price is less than 40. Now consider this range, between 40 and 50. Okay? The call is not in the money, neither is the put. So it's 0 minus 0, which is 0. Okay? And then finally, when ST is greater than 50, the call option is now in the money. Because if the stock price ended up being 60, we'd make 10. If it was 70, we'd make 20. So that's what you get. And the put option is not in the money, so we lose 0. So that's the function for the put, for the call and the put. Okay. So that's just a short example, and I'll go through one that's a little more involved now. This, by the way, these are the payoff profiles for each of the 4 individual options. Okay, or the 4 individual option strategies. If I wanted you to draw the payoff of an option strategy that consists of a bunch of options, it's not enough just to show me a bunch of these graphs. I know what these are. What you have to show me is, okay, if you combine these together, what kind of shape do you get? Do you get a shape that looks like a triangle? Do you get a triangle that has a flat spot in the middle? So you have to know how to draw these. So I'll go through an example here. Okay? So in this one, we have a business that suffers when there's uncertainty in the economy, much like a lot of business. And we'll say that uncertainty represents itself as high price volatility. Okay? We want to create an option strategy that hedges against some of this volatility. So we basically want to create an option strategy that's profitable when stock prices are volatile. There are many different strategies you can use, actually. but we're going to use one that's somewhat cheap. Okay? So specifically, we're going to enter into these following positions. We're short a put with strike price 30, long a put with strike price 40, long a call with strike price 60, and short a call with strike price 70. Okay? So if you're short a put that is strike price 30, what is the payoff? What is the general payoff of that strategy? Does anybody know? Short a put. I'll understand that as negative of the max of k minus st comma 0, where k is equal to 30. Thanks. And so if you're long a put with strike price 40, then the payoff is max of 40 minus st comma 0. Okay? So, first of all, in the first question of example 3, I asked you simply, how much does this option strategy cost? Okay? Remember, when you're long something, you're buying it, so that's going to cost you money. If you're shorting it, you're selling it, which means you're going to get some money. Okay? And I'm not dealing with bid and ask prices in this column. Yeah?
Are these equations on the sheet that you're going to give us, or do we have to memorize these ones?
They will be on the sheet. I'm going to put the sheet on Blackboard today, so that you guys know exactly what equations are going to be on it. Okay? So, in this example, well, how much does the long put cost with strike price 40? It costs $5, right? So we have to pay $5 for that put. We're long a call with strike price 60. That costs $8. So we have to pay another $8. Okay? We're short a put with strike price $30. These puts cost $3, so that lessens our cost. And then finally, we're short a call, and those cost $6, but we're shorting it, so we get back $6. So the cost is 4. Okay? And now, part B, I asked to draw the payoff function of this strategy, okay? So, we're going to put the state of the stock price at terminal date here, and I'm going to put the payoff here, okay? So the payoff is equal to, well, we're short that first put, right? So that would give us max of 30 minus st comma 0, the negative of that. The next put we're long, so that's positive in front, and that's 40 minus st comma 0. Okay? The call at strike price 60, we're long that, so it's max of st minus 60 comma 0. And then finally, it's minus max of st minus 70 comma 0, because we're short that call. Okay? So, does everybody understand where this came from, this payoff?
What does ST mean?
What does ST mean?
Yeah.
That means the value of the stock at the date of the expiration of the option. So the final stock price. So if the final stock price ends up being $70, then you made $10 on your third one, right? Because max of 70 minus 60 comma 0 would be 10. And these wouldn't be in the money because 40 minus 70 would be negative 30. And 0 is higher, so that would be a 0, as would this one. Okay? So that's what the payoff looks like, which is basically, I just went back to those equations that I gave before, the 4 equations for the 4 different simple option strategies, and I just plugged those into here. You know? So this is the short puts, this is the long puts, this is the long call, this is the short call. Now, how many states do we have to consider? There are 4 strike prices. So we have to consider 5 states, okay? So the first state is, we'll start at the lowest, when ST is less than 30. So when the final stock price ends up being less than $30, okay? Well, let's look at the payoff. This first one, it's going to be the negative of the max of 30 minus ST comma 0. So if ST is less than 30, let's just say it's 20. Then, well, the max of 30 minus 20, comma 0, would be 10. So that would be a minus 10. But we're just going to do this for general ST less than 30. So,